So this is a tutorial on all the parts that we're going to use in the Electronics 9 course to get you started. Okay, so I'm not going to do these necessarily in order, but I'm going to cover them all. So the first part that we're going to talk about is resistors. Okay, so there's my resistor, and resistors come in different shapes and sizes. So there's a small little guy, here's one a little bit bigger. Okay, and resistors are simple. They slow down or restrict the flow of electricity. Okay, so you have, let's say, a water tap, and you have the tap wide open. Lots of water comes out, which means lots of electricity is flowing. Whereas I take the tap and I turn the tap almost off, little bits of water drip out, okay, which means there's very little water or very little electricity flowing through. Okay, and that's kind of what a resistor does, as an analogy. Now, resistors doesn't matter which way I put them in. I can put them in this way, I can flip around, does not matter. They don't have a positive negative. Okay, and when I grab a pencil, I'm just going to look at these. Actually, I'll grab a bit bigger one. Okay. Oh, where'd my other resistor go? Oh, forget it. We'll just use this one. Okay, hopefully you can see this. So, the colors on a resistor, there's always going to be 4 bands in this room. Okay, and the colors are going to go, there's going to be a gold band always, and there's 3 other colors. So, when I read it, I always put the gold band, okay, or read the gold band last. So this one goes brown, black, orange. I know brown represents the number 1, so that's the first digit. Black represents the number 0, so that's the second digit, so it's 1, 0. And then orange represents the number of zeros. So orange, it happens to be the number 3, so it goes brown, black, 1, 0. 3 zeros would be 10,000, and you can shorten it up to be 10K. And we'll explain a lot of that later and do a lab on this. Okay, but that's resistors. It slows down the flow of electricity. Okay, next is an LED. LEDs have what's called an anode and a cathode. So when you look here, you're going to see that one leg is longer than the other. This is the anode. I'm just going to bend this apart a tiny bit. Okay, so that's the anode. And then the shorter leg is called the cathode. Okay, so when you hook these up, the cathode has to go to negative side of your power of your circuit so that electricity can flow through it properly. If I reverse it like this, then the LED wouldn't light up. Okay, so long one's anode, short one's cathode. If I cut them the same length, I'm going to flip it this way. What happens is, and let's see if you can see this, is right here there's a flat bar on there, and I don't know if you can really see that on this video. Okay, but there's a flat spot across the LED. That's the negative side or the cathode side of the LED. So if you cut them the same length, that's how you tell the negative side. Okay, and an LED, again, you have to put it in one way, because if you put it in the wrong way, it won't work. Okay, the next part in this series I'm going to use is a potentiometer. Potentiometer is very simple, straightforward. There's 3 legs. One leg, the middle leg, is used. One of the outside legs is used. That's all you're going to use them for now. Okay, and basically a potentiometer is a variable resistor. So when I turn it, you can see the thing's turning. Okay, when I turn it one way, it'll have no resistance between the center leg and the outside one, and no resistance means it's like a short circuit and lots of electricity is flowing through it, and you would burn this up. Okay, and if I turned it the other way all the way, what would happen is I would have lots of resistance, the maximum value. And you can read right here, okay, this is a 10K. You want to be using a 100K one or 50K potentiometer in your labs, so don't grab a 10K one. Okay, but basically middle leg, outside leg, and it doesn't matter if it's middle leg, this leg over here, or middle leg and that leg over there. And all it does is slows down the flow of electricity. Now, where are they used? Really simple. Think about a stereo or your alarm clock, right? I turn it and my volume goes up. I turn it the other way, my volume goes down. That's the easiest explanation of what a potentiometer does. Okay. Next one, photocell. Photocells do not have a positive or negative. The legs are the same length, right there, and you can hook it up that way or this way in your circuit, and a photocell simply reacts to light. So the more light that strikes it, the less resistance it has. The less light that restricts or hits it, the more resistance it has. So when I put my hand over it like this, the resistance would go up, and when I take my hand off, the resistance would go down. Which means if you had a light connected to it, the more light that strikes, the brighter the light would be, and when I put my hand over it, the dimmer the light would be. I hope that makes sense. That's pretty straightforward. Where do you see these things? Think about an automatic security light on the side of your house. Does it go on during the day? No. If you look closely, you're going to see one of these guys in it. So when it gets dark out, it senses, hey, it's dark out, Now let's turn the security light on. Otherwise that'd be a waste of electricity every time somebody walked by it during the day, right? So that's your photocell. Moving on, diode. Diode, remember an LED? I called it a light emitting, or I didn't call it a light emitting diode, did it? So an LED stands for light emitting diode. A diode just doesn't give off light. So a diode has a positive negative side, which are called anode and cathode. Anode goes towards the positive side in your circuit. The cathode goes towards the negative side in your circuit, and electricity can then flow through it. If I reverse it, the electricity gets blocked. That's the simplest way of explaining it. So if I want to stop electricity from going into a circuit the wrong way, I put a diode in. And that way, if I hook my positive negative up backwards, I don't wreck my circuit. Okay, so diodes are used all sorts of places, and you just got to know that the silver line is to the cathode, and the black side goes to the anode. Okay, that's my diode. Okay, moving on. Let's go to capacitors. Okay, so down here, two different capacitors. Okay, these ones are called electrolytic. You see how one leg is longer than the other leg? I think you can figure out by now that the long leg goes towards the positive side. There is no anode cathode. Okay, and the short leg goes to the negative side. Now if I take this and I bring it up closer, you're going to see on the back side, see that gray line right there? Okay, that represents the negative side. So if I was to cut it the same length, I can recognize that that is the negative side. Okay, and capacitors are simple. They store electricity. So the bigger the capacitor, the more electricity is stored. And then when you need a flash to go off really quickly in a camera, there can be a quick little burst, whoops, let me do this right, burst of electricity so that the flashes will be bright and intense. Okay. The other capacitor is just this little guy. This guy's called a ceramic capacitor or disc capacitor. And they, same thing, they store electricity, not very much electricity. Right? These guys here, they're pretty simple to read. On here, they'll say a voltage, and they'll say what they are in microfarads. So UF, so they'll say 10 UF or 100 UF or 1 UF. These guys are harder because there's a number system. Okay, and this one says 104, and what it really means is 1 is the first digit, so it's 1, second digit, 0, and 4 is the number of zeros. And this is in picofarads. So what happens is 1 0 and 4 zeros is 100,000. And 100,000 picofarads happens to be 100 nanofarads. And 100 nanofarads happens to be 0.1 microfarads. A little complicated, but eventually you'll figure it out. Okay. The last part is called the transistor, and it's right here. And I'm not going to pick it up, but leave it here and go, okay, I have on here the letter E is this one. The center one's the letter B, the outside's letter C. E stands for emitter, B base is for base, and C is collector. So when you read it from the front on the flat side, it'll tell you what it is on there. Okay, so this one's a 3904. I have 3906s. Okay, so the 3904 is called a 2N3904, and it's called an NPN transistor. And the other one is called a 3906, and it's called a PNP transistor. Don't get confused because there's millions of these things that look like these. They're not transistors. So for example, in my classroom, I have what's called an LM335, and it's a temperature sensor, and it looks identical to this. So you got to read the front to know what you're working with. And a lot of kids don't read the front here, and they go, Mr. Class, and the project doesn't work. And I look at them and I say, well, you got the wrong transistor. Okay, so just know there's emitter, base, collector, and they are what are called transistors that basically they amplify current. Okay, they switch electricity on and off, or they can amplify it. So if you put a small amount of electricity on the base, it opens up between the E and the C and lets electricity to flow through it. If you put more electricity or current on the base, it opens them up even more. So you can actually control things like fans and motors, the speed of them, just by putting different resistors on the letter B. Okay, those are the parts you're going to use. Make sure you know how to use them. There is video on them. There are links on web pages on the website to what they all do if you want to learn more. But that's the basics of them. So enjoy working with them.